Warning, many animals were petted and played with during the making of this video. This video contains drug references and graphic images of hominin anatomy that may not be suitable for younger viewers, all in the name of science and education. Do you have a pet dog or cat? Did you know that you're getting a sort of high when you are petting your animal? And you feel these effects even when you just see or talk to your furry little friend. And your pet is feeling those effects too. We'll discuss why our pets make us feel so good and the evolutionary origin of our animal-human relationships here on Koaw Nature. This whole video started when I saw my sister sniffing her baby, which then led to months of research. Enjoy! I am Koaw, and Koaw rhymes with boa to help you remember. If you respect nature and you enjoy the outdoors, then you are welcome to join the team by subscribing for free. So yes, the high we are talking about today is not resulting from the physical ingestion of a substance. I am not suggesting that you are getting toasted from hotboxing your bathroom with your dog or doing lines of catnip with your feline. I hope you're not doing those things. But I'm talking about the endogenous bio and neurochemical reactions, that is, reactions originating within your body that are triggered from your sensory interactions with your pet. These reactions mimic many of the effects we experience from various drugs like cannabis, alcohol, ecstasy, nicotine, and others. Effects such as improved sense of well-being, lessened anxiety, decreased pain, changed appetite, altered mood, greater sociability, and there are even healing qualities. And this animal bond we have with our pets has been a co-evolutionary relationship in the works for hundreds of thousands of years, epitomized by the first domesticated animal, the modern dog. We know that the direct ancestor of Canis familiaris, better known as the modern dog, is Canis lupus, the gray wolf. For at least the past 400,000 years, wolves and hominids had been closely interacting with one another, evidenced by wolf bones found in and around hominid cave dwellings. It would be hundreds of thousands of years later before any wolf populations evolved into the modern dog, and the exact timing and locality of this domestication is still widely debated within the scientific community. We do know that the first domesticated dogs were present at least 15,000 years ago, and possibly up to around 45,000 years ago. But we don't know if the wolf-to-dog lineages originated from a single Eurasian source or possibly from dual domestication processes. And Felis catus, the domesticated cat, would not become a domesticate for thousands of years after the modern dog came to be. Contrary to popular belief, Egypt is not where we find our first evidence of the tamed African wildcat, or the species of wildcat with direct lineage to today's domesticated cat. Rather, our earliest evidence of cat domestication is a 9,500-year-old grave holding an 8-month-old cat found alongside human remains on the large island of Cyprus. This entombment occurred during the Neolithic, or the last division of the Stone Age, and probably was from a hominid group traveling from the Levantine coast or the eastern shore of the Mediterranean Sea. This cat suggests that people were domesticating the African wildcat just as humans were establishing agricultural settlements in the Fertile Crescent of the Middle East. We'd also find archaeological evidence of cat domestication from the African wildcat in Israel from around 9,000 years ago and in Pakistan around 4,000 years ago, as well as other places and times across Eurasia and Africa. The ancient Egyptians, a culture that revered cats, would later play a paramount role in the global distribution of the domesticated cat. However, the dog will always remain our oldest companion, as we domesticated the gray wolf into a dog before we domesticated any other animal, or even before any plant. The dog truly is our first best friend. And it's actually this strong human-to-dog bond that had me so curious to begin research on this topic. And it all started when I saw my sister constantly sniffing her baby and seemingly getting a high from it. She was all for cuddling and sweet talking with her child, and this is something I had never really seen from her in 30 plus years of knowing her. She'd always been this tough, independent person, and suddenly she was a caring mother, very attached to another human being, and clearly experiencing mental and physiological changes. And as I watched her, I realized that in my life I have done the same thing with every one of my dogs. And even though I'm often regarded as a non-affectionate, outdoorsy man, Ron Swanson was a recent comparison I received. When I'm around most animals, especially dogs, I turn into this sweet-talking, kissy-kissy, super affectionate person. And I bet you are the same way with your animals. So, after witnessing my sister and realizing how I've been with other animals in my life, I thought there has to be more to this. There must be some sort of epigenetic factors in our DNA getting triggered to create this innate and rewarding animal-human bond. And there is. And researcher Meg Daly-Olmert did well tying together a theory for the evolutionary and chemical reasoning behind the animal-human bond in her book, Made for Each Other, where she supports the notion that we are born with a neurochemical capacity for biophilia, or the desire to connect with other life forms, especially as it pertains to our pets in this situation. And she recognizes that it all revolves around an endogenously produced biochemical made of 9 amino acids called oxytocin that is capable of initiating or enhancing all of those effects we previously discussed. Yep, your body makes this fascinating polypeptide. Your cat, your dog, and all other mammals also make oxytocin. It's been around in animal evolution for millions and millions of years, with biochemical precursors existing well before that, and in birds and reptiles, a similar substance to oxytocin exists called mesotocin. Oxytocin, sometimes referred to as the hugging hormone, is a key component to why you and your pet make each other feel so good. So of course I have to tell you more about it. Though oxytocin has been around for millions of years, it has only been known to us for a bit over 100 years. In 1906, Sir Henry Dale discovered a substance in the pituitary gland that expedited the birthing process. He named it oxytocin. He'd later discovered that oxytocin also helped with the releasing of breast milk in nursing mothers, and it'd take almost another half century for us to just figure out oxytocin's molecular structure, this confusing bunch of letters and lines. There's 9 amino acids there, right? And for decades more, the scientific community believed that oxytocin was just a hormone only produced in females. We now know that oxytocin is produced in both females and males of all mammals, and it is the key player in our ability to form social and intimate bonds, like that of a mother's powerful urges to bond with her baby and the baby's desire to bond with her. It's a major component in our experience of love and our sexual activity. An orgasm causes a whole bunch of oxytocin to be released within us. And oxytocin is even important when bonding in more casual situations, like when we form and maintain friendships. It allows us to relax and create trust with another being, whether if it's when you are connecting with your cat, or when my boys are hugging after scoring a goal. We also now know that oxytocin doesn't just act as a hormone going through our bloodstream, but also as a neurotransmitter or signaling substance in the brain. Oxytocin is made in various places of the body, but notably in the supraoptic and paraventricular nuclei of the hypothalamus, where oxytocin is then released into the nearby pituitary gland and then into the bloodstream as a hormone, reaching target cells in the body. Or it can also be directly given as a signaling substance from the hypothalamus to the nervous system, communicating with and influencing the other well-known signaling substances like serotonin, dopamine, adrenaline, and the opioid system. So activities like nursing, eating, making love, and just pleasant interactions with another person or animal are able to release oxytocin not just in your blood, but also in the neural network of your brain. And again, just as oxytocin is produced in you, it's also being produced in your cats or dogs. Two South African researchers found that after dog owners gently stroked their pets while softly speaking to them, both the dog owner and the dog had practically doubled their blood levels of oxytocin and had increased levels of beta endorphin, dopamine, prolactin, and showed lower blood pressure. And we know that beta endorphin is a powerful endorphin dealing with pain suppression. And dopamine is often associated with our reward system and released when we take many types of addictive drugs. The World Authority on Oxytocin, a Swedish doctor by the name of Kirsten Uvnas Moberg, describes in her book The Oxytocin Factor how she and her colleagues also found evidence that these soothing effects from oxytocin can occur across the species barrier. By applying pleasant touch to rats, by way of stroking at around 40 times per minute, yes, they were stroking rats, it was found the rats showed increased levels of oxytocin, reduced stress hormone levels, lower blood pressure, greater tolerance to pain, increased social interactions, improved learning, and increased growth. And they found that stroking the ventral side, that's the breast and belly, was more effective than stroking the backside. Oxytocin plays an important role in our autonomic nervous system, or the bit of our nervous system dealing with our involuntary body functions. Basically what our bodies do without us having to consciously think about doing it, like our circulatory system, gastrointestinal system, and even just breathing. The autonomic nervous system is divided into two parts: the parasympathetic part, specializing on rest and growth, and the sympathetic part, specializing on defense and stress, better known as the flight or fight responses. Oxytocin is a major component of the rest and growth part, and its very similar sister substance, vasopressin, which differs only by 2 amino acids in molecular structure within humans, is a major component of the flight or fight part. Each system deals with mostly polarizing situations. When we're feeling danger, pain, hunger, or being challenged, we'll become vigilant, stressed, self-possessed, competitive, and more independent. And while we're experiencing enjoyable touch, sexual activity, fullness, a sense of safety, and positive social interaction will become relaxed, happy, sociable, sensitive, and more willing to be dependent. So generally, when our flight or fight system is activated, our rest and growth system is less active, and vice versa. It's like a seesaw with each system working along the other in a balance. And each system is essential to an individual's survival and well-being. Estrogen, the primary female sex hormone, can promote the release and reception of oxytocin throughout the body, while testosterone, the primary male sex hormone, does the same with vasopressin. Both males and females make testosterone and estrogen, generally just in different amounts. Dr. Uvnas Moberg has illuminated the many influences oxytocin has on the vital processes in the body, and she calls this system opposite to the flight or fight system the calm and connection system, because it's when this system is activated that we are able to relax, heal, and bond not only with our children, family, and romantic partners, but also with our pets. This is why companion pets have been proven to be very effective for the elderly and other individuals dealing with mental and or physical health issues. But roughly 90% of all research that's dealt with the autonomic nervous system has focused on the sympathetic part, leaving the parasympathetic part, including oxytocin, relatively much less researched. That's probably because we live in a hustle-bustle world full of hyper-competitiveness that's focused on the more overt production we see from an active sympathetic system. A system that triggers our competitive and aggressive drive to accomplish goals. We tend to overlook the more inconspicuous benefits and necessities that the parasympathetic system provides. But when the calm and connection system is activated and oxytocin is in action, we see lowered blood pressure over time and a lowered heart rate, as well as lower levels of stress hormones such as cortisol. Our body heals faster, there is improved social memory, and more willingness to achieve closeness with others and form social bonds. MDMA, also known as ecstasy, produces strong feelings of closeness and love by human users. A group of scientists decided to give some ecstasy to rats to see if oxytocin played a role in the social effects of the drug. And sure enough, they found that the rats on ecstasy were triggering the activity of oxytocin containing neurons in the hypothalamus, and the rats were more willing to be close to one another. And another group of scientists decided to give MDMA to the California two-spot octopus. They found that a dosed octopus would spend more time socializing and touching arms with other octopi. Why did I get out of academia? I could have been designing experiments and giving ecstasy to all sorts of creatures. Okay, let's go back in time. Let's go back about 2 million years to when no hominids were yet Homo sapiens, and the need to create strong social bonds was proving to become an evolutionary necessity, as this was during the Ice Age, where during glacial periods, every 100,000 years or so, big sheets of ice would consume much of the northern hemisphere, cramping together all hominid groups and other animals competing for the limited green resources. So roughly 2 million to 700,000 years ago, the hominid brain doubled in size, leading to the ability to create fire and even communicate in a basic proto-language for alliances in childcare, foraging, and overall survival. Then between a 500,000 to 100,000 years ago, the brain would again grow in size, resulting in the first Homo sapiens and a large neocortex, with a brain 3 times the size of a chimpanzee's. And the neocortex is the big part of our cerebral cortex involved in higher order brain functions like spatial reasoning, language, and cognition. Our large, capable neocortex is really what separates our species from any other on a cerebral level, even if at times our species doesn't really seem that intelligent. So the hominid neocortex had expanded in size in response to the needs for greater teamwork and intense competition in the difficult times of the Ice Age. With that brain expansion, childbirth was far more complicated because baby heads were now very large and birth had to be triggered before a baby's head became too big to pass through a mother's pelvis. So now a baby's brain at birth was only about 25% wired up, so to speak, meaning any offspring was essentially helpless, requiring a mother and child to be willing to ask for help and encourage the social assistance of others. That also meant other individuals within these social groups would need to be willing to help protect and raise a child. And what biochemical do you think was at the foundation of this boost in social cooperation? Yep, oxytocin. In Today's Women, Dr. Uvnas Moberg and her colleagues found that in new mothers, the more oxytocin in their blood, the more their behavior changed. Their social desirability increased, where they would be more willing to ask for help as well as please and obey. They would be calmer and more content and more pleasing to be around. Of course, not all women experience these changes. But our species would not exist if the crying, screaming, and helpless babies of our ancient ancestors did not only evoke the oxytocin-rich responses of their mothers and other women in the human groups, but also within the more inherently aggressive males. The old adage, "it takes a village," definitely has evolutionary truth to it. So we've seen that touch has been evidence to release oxytocin during interspecific interactions, or those interactions between different species, but not many studies yet exist for the other senses. It more than likely occurs, but that's not how science works. We have to have empirical evidence to confidently say that it does. But one study did find that dog owners who exchanged more gazes with their pet for longer intervals experienced a greater degree of relationship with their pet, and they also had higher oxytocin levels in their tested urine. So those adoring eyes asking for a treat or a ball to be thrown or a walk outside are causing physiological changes within us. And before humans could speak in any meaningful sentences, most all communication was done via paralanguage, or nonverbal communication involving facial expressions, gestures, and grunts involving tonal changes in things such as pitch and volume. This is primitive knowledge embedded into mammalian DNA and certainly not lost with the advent of our verbal language. Still, to this day, much of our communication is not conveyed by words but by the gestures and tones we make. We can often tell someone is having a bad day just by looking at them, or just hearing what's behind the actual words. So if I see this cute kitten, and I say the same words in two different ways, the meaning and reaction it causes would be completely different. Oh, look at you, I just want to eat you up. Oh, look at you, I just want to eat you up. See? So a mother cat would not be too happy with me if I spoke to its kitten using the latter of the example there. So low frequency, deep and harsh noises like a dog's growl conveys hostility and stress, while high frequency, more melodic, smooth noises convey calmness and openness, like that of your cat meowing when dinner is presented. This trend holds true for essentially all mammals and even birds. It's a universal language across many species barriers. A study published in Applied Animal Behavior Science found that when testing humans' ability to interpret the emotions of varying types of dog barks, both humans with and without previous dog experience were pretty good at interpreting the emotions conveyed by the varying types of barks. So even if you don't have a dog, you're probably pretty good at understanding your neighbor's dog when it's upset, or when it's eager to play, or it's just excited. And we already saw in our one study that gently speaking to and stroking a pet dog increased the oxytocin levels in both the owner and the pet, and there is no reason to believe the relaxing, melodic purring of our felines and the cute doggy whimpers of our dogs is not also triggering oxytocin within us. Again, if we look at the research of the World Authority on Oxytocin, the good doctor finds that rats receiving oxytocin injections experienced many effects like becoming calmer and having reduced stress hormones. But curiously, they also found that rats within the same cage that did not receive these oxytocin injections would experience similar effects to the rats receiving the injections. By giving these other non-injected rats an oxytocin antagonist, or a way of blocking their oxytocin receptors, they have found the positive effects disappeared. And when they temporarily blocked the olfactory ability of these rats, the effects also disappeared. Thus, it was shown that oxytocin's effects can be triggered not only by touch, but also by smell. And even though there really isn't any strong research yet, I would bet dollars to donuts that when a mother is sniffing her baby, and when I'm sniffing that adorable beagle, pheromones are being released that are detected, causing oxytocin to go into action. Let's now look back to our seesaw of flight or fight and calm and connection, with vasopressin as an integral part of one and oxytocin the other. We'll notice that each fosters a type of courage. One is more of a battle courage, where there is intense need to brawl or bail, and the other is a courage to explore and make new friends, sort of like that liquid courage we find in alcohol to ease anxiety and create social lubricants in group situations. And here we have early humans, flowing with oxytocin to allow for social cooperation and bonding, and also grasping the hunt of large prey. And they've been watching and living alongside another social carnivore, the gray wolf, an animal that has been successfully pack hunting large prey for far longer than hominids. So how did mankind make these large, intimidating wolves into our best friend via artificial selection? Well, there are many theories as to how wolves became intertwined into early hominid societies. But no matter how it occurred, an oxytocin-fueled courage must have been enabled to subdue just enough of the flight or fight responses in both us and wolves for the two species to come together in pleasant encounters. One theory suggests that a hunting partnership could have emerged. Wolves were and remain excellent strategists for herding large prey and picking off the sick and weak. Humans were also becoming more intelligent and crafty in their hunting tactics. And after watching one another for so long, it's quite possible the two species developed a sort of mutualistic relationship during the hunt. With two distinct groups causing chaos and spreading prey into a panic, it likely increased the odds of picking off stragglers. Any wolves that were more prone to be courageous by the calm and connectedness, that oxytocin-fed area of the parasympathetic part of the autonomic nervous system, could have found their way next to human tribes, sharing in the spoils of the hunt, where the most social and friendly wolves would be allowed to survive, have puppies, and pass on those so-called friendly genes into future generations that, after many generations, could have become the modern dog. And this interspecific camaraderie, or teamwork between different species, is not unheard of in the animal kingdom. Take the badger and the coyote. These two animals have been found to work together to capture prey such as ground squirrels. Each creature brings a different skill set to the hunt. The badger is capable of digging into burrows and flushing out ground squirrels, while the coyote is talented above ground with a higher vantage point and the ability to quickly pounce on top of prey. And even though each animal is out for its own sake, where whoever captures the prey gets the prey, and sometimes the coyote will even steal the prey from the badger, each animal's odds of being successful during these temporary teamwork hunts is better than if they were hunting alone. They've even been observed touching noses while interacting, and even having body-to-body contact while lying down and resting. They're high on that oxytocin-induced buddy love right there. Wolf pup adoption is another theory. Baby mammals often have many traits in common that are recognized across species barriers. Baby mammals often have big eyes, bulging foreheads, and often emit sounds that we and most mammals immediately think of as cute and non-threatening, and we feel inclined to come help or just come in for a snuggle. It's quite possible that these adorable mammal qualities in wolf pups appealed so greatly to our ancestors that certain abandoned pups would be adopted. They would be welcomed and even suckled by women of a tribe. And women breastfeeding other animals is nothing new. It has been done for ages across many cultures for various reasons, and it's even prevalent in many cultures today. And again, only the most social and friendly wolf pups would have been allowed to remain within a human group, thus passing on those friendly genes into future generations and so forth and so on to where the dog would eventually arise. Another theory is that of trash pile scavenging, where perhaps rather than being hunting partners with humans, wolves were just more opportunistic at picking off the scraps of mankind. Wolves that hung around campgrounds and cave dwellings eating whatever leftovers they could find were probably welcomed, as they could ward off other predators, or at the very least warn the humans of incoming threats, including that of other hominid tribes. And this trash pile scavenging theory is somewhat applied to how the African wildcat evolved into the domesticated cat, though the only difference being that by 9,500 years ago, when we find our first evidence of cat domestication, humans had already figured out how to domesticate crops. Ergo, there was agriculture. With agriculture comes grain, and with grain comes mice. So it's theorized that the house mouse around these agricultural settlements became an alluring prey source for the African wildcat, and certain wildcats with friendly enough demeanors would be allowed to stick around and eat some mice and eat snakes and be invited into the homes, and after much time and many generations, the domestic cat would come to be, to make that evolution simple. And there's no question that dogs and cats offer us quite different relationships as pets, but both are quite capable of being those oxytocin-inducing stimuli that make us feel so good. And we see such diversity in the modern dog because we've created breeds to help with various tasks, be it sled pulling or hunting or protection, while cats aren't really so keen on doing tasks unless they want to do them. Cats have really just been doing their own thing over the centuries. Thus, selective breeding has been relatively minimized, leaving the domesticated cat rather homogeneous compared to all our dog breeds. And though we don't really have the research yet, it fits in the theory that your other pets like reptiles, fishes, and birds can release the oxytocin within you as you interact with and admire them. And I would even say that E.O. Wilson's hypothesis of biophilia, or the notion that we humans have an innate urge to affiliate with other forms of life, is quite spot on and can be strengthened into a solid theory if we begin more studies measuring the oxytocin blood levels of people enjoying the outdoors and interacting with wildlife. I sure know that when I'm outdoors, seeing a beautiful insect, or an active bird, or a colorful salamander, or a lively fish, or a graceful fox, it all makes me feel very similar to how I feel when I'm giving a dog a nice pat on the belly. It makes me feel relaxed and in a better mood, and it makes me feel high in that good old natural way. Oh, it feels good to get this video off my chest. I made it as a promise to a Jaguar patron, Natalie. She is also in a video I'm linking right here or down below where she debunks nuclear myths because she's a nuclear expert. You should check that out. And the names you're seeing on the screen right now are my patrons from Patreon. They toss me $1 or more every month so that I can keep making these videos for you. We spread knowledge and we are nature heroic, and that's how we do. And I have an idea. If you want to support and you want to just cut back maybe on a spliff or a beer or a coffee once a month, every few months, you could be a part of something great. It's patreon.com/Koaw. All relevant links are below, as well as my sources for this video. Now it's cheers.